So in this situation, we can write the potential energy as U of R, potential energy, equal to 1 divided by 4 pi epsilon 0, 4 pi epsilon 0, 1 by R2 divided by 1 by R1. R2 minus R1. 1 by R1 is infinity, 1 by infinity is 0, 1 by R2 is 1 by R. So it is Q into Q0 divided by R. So this is the another form of equation for potential energy, where we have moved the charge from infinity to the point B at a distance R. Okay, charge move is Q0 from infinity in the presence of charge Q. So that is nothing but an equation for potential energy. Here we have done. Now let's go further. What are the unit of this potential energy? As we know, the potential energy can be measured in joule. So definitely joule would be the SI unit of this potential energy, can be measured in a joule. Apart from this, the another unit of this is nothing but what does mean by joule? Might be all of you learned the definition of joule in 8 to 10 standard. Still they have mentioned here again. 1 joule is energy stored in moving a charge of 1 coulomb. 1 joule is amount of energy stored to move the charge of 1 coulomb whenever there is a potential difference of 1 volt. Then that energy stored is said to be 1 joule. Another unit of this is nothing but electron volt. What exactly electron volt means? So they have mentioned the electron, which is a change in the kinetic energy of electron. Change in the kinetic energy of electron while crossing the 2 points maintained at a potential difference of 1 volt. Change in kinetic energy. This was electron volt measured in kinetic energy, remember. Then it is said to be 1 electron volt. So 1 electron volt can be represented like this, electron volt. 1 electron volt is equal to 1.6 into 10 raised to minus 19 joule. So this is the formula for joule and electron volt relation. Again, 1 milli electron volt equal to 1.6 into 10 raised to minus 19. It is millivolt, means what? Into 10 raised to power minus 3 joule. Minus 19 minus 3 is what? 1.6 into 10 raised to power minus 19 minus 1, 20, 22 minus 22 joules. 1 kilo electron volt is again equal to 1.6 into 10 raised to minus 19. It is kilo into 10 raised to 3 plus 3 it is. So it gets subtracted here, 1.6 into 10 raised to 3, 10 raised to minus 16 joule. So these are some of the another unit to measure the potential energy. Let's go to concept of potential. What exactly electric potential that we want to learn here? Concept of potential. So just we have written one equation up till now. The equation for electric potential we have to learn. So electric potential. Electric potential and potential energy are different. Okay, so electric potential, just we have written one equation, V U of R, potential energy U of R. What is that U of R equal to? Just before we have written U of R equal to 1 divided by 4 pi epsilon 0, 1 divided by 4 pi epsilon 0 into Q1 into Q2 divided by R. Initially we have taken this as a capital Q and Q0. Here we have taken Q1, Q2 are the charges. Then the same thing can be written as 1 divided by 4 pi epsilon 0, 1 divided by 4 pi epsilon 0. So here it is Q divided by 4 pi epsilon 0 into R, Q1 divided by this into Q2. Equation remains same. Same thing can be written as Q2 divided by 4 pi epsilon 0 into R into Q1. Still the equation remains same. So in this fashion you can write these two equations. Now here V of R is nothing but electric potential is nothing but it depends on a charge. This term is said to be electric potential. This is for Q1, it is said to be V1 of R. Okay, into Q2 equal to V2 of R into Q1. So we can write like this. So V1 of R means what? Electric potential due to charge Q1. Electric potential due to charge Q2 is V2 of R. So if you see, sorry, you can't see this here on the screen. So just I shaped the mobile. So I will just try to explain again, because you can't see the screen now. So just see here we have represent this equation by this. According, just we have to write equation for potential energy U of R 1 divided by 4 pi epsilon 0 Q1 Q2 divided by R. Initially we have taken capital Q into Q0. Here we assume there are two charges are Q1 Q2. Then we can write the same equation as Q1 divided by 4 pi epsilon 0 R into Q2, or can be represented as Q2 divided by 4 pi epsilon 0 R Q1 outside the bracket. Both equations are same. In this case, this bracket term is said to be Q1, so it is V1R. Q2, it is V2R, and they are said to be electric potential. Due to charge Q1 is V1R, due to charge Q2 it is V2 into R. Now remember, so this is the potential energy U of R equal to. Suppose we want to find out V1 of R or V2 of R, that is nothing but electric potential. In general, you can write equation, the potential energy U of R equal to electric potential V of R into charge Q. In general, we can write this from these two equations. So we want to find electric potential. So electric potential equal to potential energy divided by charge, or electrostatic potential energy per unit charge is said to be electric potential. So this point we have learned up to this, but we know what is this electric potential. So the potential energy, it is the work done itself. Another way you can write the change in potential, electric potential between the 2 point 1 and 2. Suppose we can write this as V2 minus V1 equal to what? U means U2 minus U1 divided by charge Q, and this U2 minus U1 is change in potential energy, and this change in potential energy itself is nothing but what? Work done, change in work done or amount of work done required per unit charge, and that is nothing but what? Electric potential. Now let's go to next, relation between electric field and electric potential. Relation between electric field and electric potential that we have to learn. But how they are related? Relation between electric field and electric potential. So just directly remember one equation, E equal to minus dV by dx. Here dV by dx is said to be potential gradient, electric potential gradient, how the electric potential changes with the distance, and electric field is represented by E. So E equal to negative of the potential gradient. So this is the simple equation which will give the relation between electric field and potential gradient. That's it. You have to remember this directly. Then there is a zero potential. What exactly is zero potential that we have to learn? So let's start with the zero potential. Zero potential is one of the concepts where we assume that on the Earth's surface, whenever we do the electrical connection, we know that we have the three electrical connection. So this one is there, and this one and this one. So three pins are there. So this would be positive, this would be negative. This is for what? This is said to be ground. This is said to be ground. And finally, throughout your whole house, this ground connection is given to the Earth. So we assume that Earth is a grounded. Ground connection means Earth is at a zero potential. So that is one of the best example for this. So potential at point, so this zero potential on the Earth's surface is nothing but a ground. I think it is sufficient to understand. We don't go further, otherwise a little bit confusion may get start. Let's go to next topic of our syllabus. What is that next topic? Electric potential due to point charge. Electric potential due to point charge. Suppose we have very small charge, point like charge, how the electric potential can be find out from that. So that we have to learn here. For again, we have to draw the diagram. So electric potential due to point charge that we have to find out. So to find it out, electric potential due to point charge, we have to draw the diagram. So let us draw the diagram here. So I will draw the diagram like this. Okay. So here again there are 2 points. Here it is a point O where we have kept some charge plus Q0 plus Q only, small q. There is another point A at a distance of R from O. So this distance is nothing but a small r, point A. There is another point M somewhere here, M, and this distance from this point M to the O, that was represented by this line, and that distance they have mentioned as a x. This distance is x. Somewhere here another point N just behind the M, and this distance is suppose dx. This distance is suppose dx. And further, we know that this is electrostatic force, so that is Fe moving to right hand side. Is that clear? Or we can say Fe or electric field is moving to this side, so we can write this as electric field like this. So electric potential due to point charge that we have to learn here. So let us consider the charge is kept at infinity or infinity, another charge is kept, another charge they have named as unit positive charge. Unit positive charge. So unit positive charge means what? A charge whose magnitude is +1 and is positive. So unit means 1, positive means plus, and this is said to be charge. +1 charge move from infinity to M and from M to A. How much work done is required? That we have to calculate. Once we calculate the work done, we get what? Potential energy and electric potential can be find out. So here, to find this electrostatic potential, so first of all we have moved the charge from infinity to the point n. Suppose m to n and n to finally at A. Okay, in this fashion we have to find out. Suppose the charge is moved from m to n. Suppose this is at infinity, m to n. Charge is moved from m to n by distance dx, as we have done initially. What is the work done? The work done can be given by force into displacement is dx. Force into displacement is dx. Same can be written as minus sign because electric field is moving in that direction, we are moving in opposite direction. So it is minus F into dx. Force is moving in this direction and displacement is moving in this direction, minus F into dx. Just if you remember, we have find out the value of F by Coulomb's law. What is F? Here is 1 divided by 4 pi epsilon 0 q1 into q2 divided by r square. This is a Coulomb's law we have learned. But here q is here. What is q2? So instead of q1, q is there. q2 is what? It is +1 unit positive charge. So you can write this is nothing but a force. Second charge is +1. So put it here. We can write this work done as -1 divided by 4 pi epsilon 0 q divided by r square we have taken. Here it is x. So you should consider this as a x square. Q divided by x square into dx. This is the amount of work done required to move the charge from infinity to the point n, suppose intermediate point, suppose n. Now we want to find total work done required to move the unit positive charge from infinity to the point A. Total work done required, so that it will move from infinity to A, means infinity to R. So we can just take integration of this. So we can write integration of -1 divided by 4 pi epsilon 0 q divided by x square into dx, where charge move from infinity to R, means infinity to the point A. And that will give what? Total work done W. That will give what? Total work done W. Here we have just written this equation. Now as we know, this q divided by 4 pi epsilon 0 does not depend on this dx, so we can take it outside and just we can write the remaining term to the side of the blackboard. I will write to this side. The further term we will write it here. So we can write here work done W equal to integration varies from infinity to R. Sorry, first we have to take that particular things common, then we have to write this. So just as 1 divided by 4 pi epsilon 0 q does not depend, so minus q divided by 4 pi epsilon 0, that is not a variable, so integration varies from infinity to R of 1 divided by x square dx. 1 divided by x square, just move this x square to numerator, power becomes what? Just we have done x to the power -2. So we can write this as x to the power -2 dx. Again apply the same formula we have applied. So what we get? Minus q divided by 4 pi epsilon 0. What is the integration of this? X to the power -2, x to the power -1. -1 into x to the power -1. So it can be written as -1 by x, and limit varies from infinity to R. Same thing. So minus minus become plus, q divided by 4 pi epsilon 0, minus minus become plus, upper limit minus lower limit, 1 by R minus 1 by infinity. 1 by infinity is 0, so this comes to be 0. So what we get? Equal to 1 divided by 4 pi epsilon 0 into q by r. That is the work done itself, and this work done can be represented by electrostatic potential at A due to charge q. This work done itself is nothing but an electrostatic potential represented by V. Is that clear? So in this fashion, we have find out electrostatic potential at point A when we move the charge unit per charge plus 1 from infinity to the point A. So this equation for electrostatic potential, we have just derived that equation. Now here, if we consider in this case, we can say electrostatic potential inversely proportional to R. Inversely proportional to R. And what is electric field intensity? Electric field intensity is found to be and inversely proportional to R square. Inversely proportional from this equation, it is inversely proportional to R square. So same, these two equations can be plotted in terms of one graph as they have plotted in your book. Let's plot them according to the book. So we can write this like this. So these are the y-axis and x-axis. On x-axis we have taken distance, so it is a distance, that is nothing but r. On y-axis what we have taken, the two parameters we have taken at a time. One is nothing but electric field vector, electric field intensity we can say. Second is said to be the electric potential. Now here if we draw the diagrams, it comes to be, this is the diagram for E and this is the dotted line diagram for V. Why they are differing? Because it is indirectly proportional to R, it is square. That's why there is a change here. So this is nothing but what? Electric potential variation with the electric field intensity variation with the distance that we have derived. Up till now we have just seen only two equations. I think it is better to stop here because it can create a lot of confusion in mind. So try to read my, try to watch my video on this topic. After watching my video, try to read the same topic from your book. Then definitely you get better understanding of the topic. Let's see in the next video with the next equation for electric potential due to electric dipole. Di means two charges, plus and minus. Two charges plus q minus q are taken, and in that case we have to find out electric potential, and then we have to find out electric potential due to system of charge, large number of charges. Then this topic gets finished. Then we start with the next one, electrical energy of 2-point charge and dipole in an electrostatic field. That will start in the next bit. So I hope you understand whatever I taught you. So just take care and try to watch my video and try to understand the topic. Thank you.